We are. We're a minute early. Should we start it all over again?
Yeah. Yeah, cut it out. Let's go back to the green room and hang out for a little bit. Are we live already?
Yeah, we're live.
Sweet. Very cool. Very cool. So, first off the bat, we have some special news for you guys. As you can tell, Chris has been fired and he's been replaced by the one and only Mr. Jim Bergmann, who's now going to be a permanent staple of our show. Every single week, without a doubt, he's never going to miss an episode. Now, truth is, I trimmed my beard, and Chris came on earlier in the show. He didn't recognize me, and his mom said, "Don't talk to strangers," so he clicked off and ran away. So he won't be here tonight because he's scared of things. Actually, he's out doing his paddleboard thing Isn't that right?
Yeah.
Paddle Pud Chud.
There, that's the name.
Yeah. That's his name. Paddle Pud Chud. Paddle Pud Chud. So without further ado, let's say hi to our number one guest, Luke, and his little buddy Randy, hanging out there.
Hey, Randy.
Where are they from? Washington, Tennessee?
Somewhere.
No.
One of those states that serves pizza. One of them. I can't remember which one.
Either.
But yeah, we got the one and only Mr. Jim Bergmann from MeasureQuick.
Awesome.
All right, turn that off.
Super excited for this show, because last time we had Jim on, we were left with a lot of sort of unanswered questions, conversations that were left open-ended, and a lot of fun things that didn't get handled.
Yep.
I don't know, Joe had a lot of complaints that he wanted to get off his chest about MeasureQuick that he's going to address tonight. Right, Joe?
Sure. All right, guys. Well, thanks a lot for having me, and I will catch you on the next one.
Not making this awkward at all.
Right? So, thanks, Bill. Way to go.
We got all good things to say. It's a great service. It's going to level the playing field and change the industry for the better. 1,000%.
Well, we hope so.
Go ahead, Adam. You can start.
Yeah. So let's see here. Let's get to the list here. First off, I want to ask Jim, like, what's like new and exciting? Like, what's the new, anything new technology you're working on?
Well, I mean, we're working on several new tool integrations. Some I can talk about, some I can't. We're going to finally get the field piece 680 and 480. I think the two electrical meters, the guys are wrapping them up now. We got the meters talking. Now we just got to get them mapped over to the different points. We've got we're doing a lot on the cloud side for pre-population, so you can like go in and get projects set up and assign them to techs before they actually go out to the job site. Because right now you have to set it up on the job site. You know, if you're not within a quarter mile of where you're working, you won't see it, because we didn't want to bring up like a list of 10,000 sites somebody might have. We just want to bring what's in your local area up. So that's in there, but it'll allow you to do some things like that. And we've been working on those are probably the biggest things we've been working on, along with just like general optimizations to the application software, making things work smoother. There's always, I mean, we have a 2-year development roadmap. There's always like a laundry list of things I can't even think of. I think we just rolled in the UEI Hub 8 because we had some people that were buying that kit and wanted the UEI 8 in there. We had the 6 in, but not the 8. And then probably the biggest things we added most recently were multi-circuit and multi-stage. So you can do up to 4 stages of cooling or up to 4 circuits simultaneously with like 30 probes, the field piece probes. So there's a lot of cool stuff going on. It's just it's a ton of odds and ends, more than anything.
I know you've been there has been an integration in place with ServiceTitan for a while now, and I heard that you possibly are looking at House Call Pro as well too.
Yeah, we've actually talked to them. We're going to slow down for a little while. I mean, we program almost consistently. And you can see how fast the updates come out to MeasureQuick all the time. Seems like there's an update every other day. And we're to the point now where we pretty much figured out how everybody wants to use it. So we're sort of backing up and rebuilding some of our frameworks. Because when you do a software application like this, it's sort of like the first time through, it's built. You really don't know how people are going to use it. So you come up with what we call a minimum viable product. You get it out there, and then somebody wants this or somebody wants that. You sort of attach it on. It's not like an engineered solution. Then after you spend about 2 years of working through it, and you figure, okay, this is what people want to do, then you got to sort of stop, back up, put new frameworks on it, but then engineer the solution. So it's like you're actually designing it to do this. It's not cobbled together. So you guys don't see, everything looks like it runs great on the front end, but sometimes there's like duplicate code base in there. There's things that we could make the app smaller, make it faster, just make it overall easier to use. So, and easier for us to program. That's the other thing is, you want to make it easy to maintain. So every couple of years we stop and then re-engineer it a little bit. And that's where we're at right now. So like doing a house call pro integration. We're just waiting till we got our house in order, and then we're going to go back and do that. But part of the challenge is just we have so many things going on at once around here. It's like just getting stopped to do that. It's been a challenge the last couple of months. So
now
we're getting close.
With ServiceTitan, does that actually, so if you have model and serial number in ServiceTitan and or MeasureQuick, will it transfer the model and serial and all the data over, as well as the benchmark readings and everything?
So out of ServiceTitan, no, at least right now, because at the time when we did our initial integration, ServiceTitan had model and serial, make, model, and serial as sort of a string. So they just had it as one lump of data instead of the way it was managed in ServiceTitan really wasn't designed to bring it into MeasureQuick and be able to parse it. It's not even comma delimited. It's like just a string of data in there. So we're just talking to ServiceTitan the other day just to see if they have it. But for us, we just store it in our cloud, so we're pulling in, think of ServiceTitan's a CRM and MeasureQuick is all about the measurements. So we manage the models, the serial numbers, the benchmark, all that kind of data. And then, ServiceTitan's going to manage the customer relationship management piece, but we're trying to eliminate some of the duplicate data entry because a lot of people have that data in ServiceTitan. And from what I understand, ServiceTitan may have changed that, but we haven't gotten an updated API yet for that. So, as soon as we get it, we can probably improve that.
Nice.
Seeing, I want to switch topics here, Adam. Seeing John McMaster in the chat here, the master of BMS control on his own house system. I want to talk about the BMS of HVAC, which is the Sensi, you could say, Predict. Because I don't know much about it, and I know Adam has tons of questions. So I don't know, Adam, you start, and then I'll just come in. You start with your first question on Sensi Predict, because I got just a little couple.
Well, I guess I was just wondering. I've gone through the class, but to talk about it to anyone who is watching right now, what are the benefits of pairing Sensi Predict and MeasureQuick together? Why would somebody want to do that?
So, it's interesting. I don't care whether you're putting in a thermostat or you're putting in a Sensi Predict, right? It really comes down to you're either, if we're talking about a thermostat, we're talking about better controlling a poorly operating piece of equipment. If we're talking about Sensi Predict, we're talking about monitoring a poorly operating piece of equipment. And it all comes down to you've got to get the equipment running right before you're going to get the real benefit of a Sensi Predict or a thermostat. The whole idea, we've actually been talking to Sensi, I bet you it goes back 5 years now, because as soon as we saw that product, we saw a ton of synergy, because the challenge with Sensi Predict's an awesome product, but it is a monitor. What they do is, they have 10 sets of sensors, and what it's doing is it's looking for change. The idea is, you try and do the minimal amount of sensors that you can detect what's changing. So if you think about you got a liquid line temperature sensor and you got a current sensor on there, right? So you see an increase in liquid line temperature over ambient because they're pulling ambient temperature from a weather station. So they're looking at it and they're saying, okay, the approach, is always about 6 degrees, and all of a sudden your approach starts climbing 8, 9, 10 degrees, right? They're monitoring that. They say, oh, hey, the approach changed. Well, then they also have current sensing on there. So they say, well, did the power factor change? Because if the power factor's changing, maybe the capacitor's going bad, the condenser fan motor's slowing down. Or maybe if it's not changing, maybe the condenser's dirty then, and it's just, plugged up with dirt, because now we know the condenser fan's okay, but the liquid line temperature is going up. And so it's constantly monitoring for that change, and they have the minimal amount of sensors to actually determine whether you have an electrical problem, whether you have a fouling problem, whether you have a charge problem. They can monitor your runtime. But the whole secret of this is you get it set up first with MeasureQuick, because what was happening initially, contractors were putting this thing on, and they put it on 2 or 3 weeks later after Sensi compiled enough data. It's saying, hey, you don't have enough airflow, or hey, you've got a refrigerant charge problem, or hey, you've got a approach problem, and it was creating a secondary truck roll. So these contractors putting this stuff on, and Emerson, I think at the time, was just assuming everybody did stuff right, and they'd install this thing and they'd retro commission the system, everything would be cool, but that wasn't the case. So it was creating that secondary truck roll. And when we paired it up with MeasureQuick now, we can retro commission the system. And because we have an extended set of sensors, we have a lot more sensors than Sensi has. We can do a lot deeper dive initially into the diagnostics. And then once we get that system optimized, we benchmark it. Now Sensi has a point to monitor from. And so it eliminates the secondary truck roll, dramatically improves the diagnostics because we can send them that benchmark early on so they don't have to wait 2 or 3 weeks to really start, understanding how that equipment operates. Right now, MeasureQuick said this is what it's supposed to do, and then let it run. So it makes the whole system work better. And then when you come out to service it, because MeasureQuick is actually integrated with Sensi, so we can pull in the electrical readings and things like that. You get an extended sensor set with MeasureQuick now, and we can pull in the voltage, the current, the wattage, all that kind of stuff, power factor. To MeasureQuick, you don't even have to hook a meter up to things, so it just makes it an easier, a better service experience, right? And that's the beauty of those two things married together. And the whole idea behind it is there's a couple ideas. I mean, Sensi was rebranded a couple different times. If you remember, at one time it was Comfort Guard. The idea was monitor your comfort, and then it was they're really focused on predictive maintenance, and that's where it's really at today. But it's about know before you go. Realistically, it's you're going to have breakdowns, but it's if you got a cap failing, or you got a coil cleaning, or you've got a filter plugged, you can either call the customer and say, hey, looks like you just need to change your filter and see if the problem goes away. Or you can, if you have a good relationship with the customer, you go out and change the cap, on the outdoor unit, because you don't need to have them home. You sort of got an idea what's going on, change the cap out, put it back together. Or, it's just
prioritize the call as well.
Yeah, prioritize the call, get the right skill level out there.
Mm-hmm.
Yep. So it's a really cool system. I like it a lot. I mean, I put them in all my kids' house, because I just, I don't want to go to a nuisance service call either. So it's,
so that reminds me of a question I was going to ask you earlier. Beta testers, do you actually have beta testing systems or beta testing homes, or is this, are your kids' homes?
Well, no, Sensi Predict's been around for a couple of years now. I mean, they're way, way, way past beta test. This thing's, there's probably probably approaching 10,000 Sensi Predicts installed, if not more. I don't know the number right offhand. I mean, so it's got a lot of them out on the market. Yeah, it's pretty substantial. People don't realize sometimes how big it is.
So I'm assuming they're using some kind of thermistors. I have no idea, thermistors to just to check temperature.
Yeah, it's got they are using thermistors. They got a liquid line and a suction line thermistor that are mounted inside at the evaporator coil. Then they've got a supply air and a return air sensor, also thermistors that are measuring return air, dry bulb, supply air, dry bulb, so they get temperature split across the coil for both heating and for cooling. And then they got a CT down in the furnace that measures current, and they are also measuring voltage through a transformer. So it's got an inside transformer and an outside transformer. And it's a special transformer that measures voltage, power factor, and current. So they can actually measure up to 10,000 times a second on that device. So you can see things like a call for ignition. You can see, you can see literally everything. You can see the spark igniter going. You can see if the gas valve energized, the whole 9 yards. Then outside, it's got another CT outside and a voltage monitor, and then also it does all the calls. So it knows if it's calling for heating, calling for cooling, calling for fans. So you can see. Was it calling and was it running? So it's saying it shows you the fan's calling and it's drawing 2.2 amps, and the condenser's calling and it's drawing 7.8 amps. And here's the wattage, here's the power factor, here's the suction line temp, here's the liquid line temp, here's the temperature split across the coil. Right. So it's pretty slick. And if you think about a typical home, you have your thermostat set at 74 degrees or whatever it is. Your split, when we're out in the field and we're calculating target temp split, it can be 16 to 28 degrees. But that's because when we're going out there, we got this crazy humidity. It's out of control. Humidity's through the roof, and we got to get the back under control. But once you get it under control, your temperature split's typically running somewhere around 18 to 22 degrees. It dials in, and then once Sensi sort of knows how your house runs, it can dial it in even closer and say, okay, now we know we're looking for temps put between 20 and 22 degrees, let's say, and we're looking for a fan watt draw of, so many watts per CFM. We're looking, these different things. So what it's doing over time is it just dialing in your appliance and sort of learning how it works. And then that's how it gets stronger, better and better diagnostics over time as it runs.
What would be the ultimate is if you're going to a flat system. That would be the opposite. That would be ultimate.
So they can tell those kind of things because they're looking at this. They're looking at the suction line temp, the liquid line temp. They can identify charge problems pretty easily. So that's been there for a long time. Won't tell you if it's dead flat, but gotcha. It'll still tell you if you got a low charge issue.
Sure.
So
one thing that I know I've struggled with, and I'm sure a lot of other people struggle with it too, is when you're doing a system change out and you have poor duct design in an existing house. And, trying to get most residential furnaces, if not all, right, are rated at 0.5 total external static. But then you start adding everything up, right? Your pressure drop across the coil, your
filter,
your filter, if you're not doing a grossly oversized filter or whatever, that's one thing that I'm trying to be very, aware of. And that kind of brings me to the next thing. We've been talking about it for a couple of weeks now, is that the TEC True Flow grid. I think that would be super valuable preparing for a system change out and commissioning a new system.
Well, and this goes to, you're using certain words, but I don't know if you mean what you're saying you mean, because when I look at a system change out, I mean a system change out. I'm talking about duct work and equipment, the duct work, the condensate drain, the electrical, getting everything up to snuff. Now, if you're talking about equipment change out, that's a whole different thing, right? Swapping out the box with a new box in there. Right. And a lot of times the box is a lot of times the box is oversized. We all know that equipment's oversized, but here's another weird thing that's going on. You got to watch. Look, I had a Moncrief furnace that was 100,000 BTUs, and it had a temperature rise of 100 degrees. It had an airflow requirement of, like, let's say 800 CFM. So I go in and I put a new furnace in. I dropped down to 90,000. The only reason I even went that high is because I needed a 3-ton drive and I had a variable speed furnace. And they did make the 3-ton drive in the smaller appliance because I do have a pretty good cooling load in the house. So I put the new furnace in. It's got a 40 to 60 degree rise. So now my airflow requirement goes from like 800 CFM on heating to 1600 CFM on when it's on high heat. My cooling requirement's only 1200 CFM. So now my duct static, which was marginal to begin with, and I'm thinking, hey, I'm going to make some ground here because I'm going to downsize my furnace. I actually lost because the temperature rise was so low on the appliance. So when you're looking at this stuff, you really got to do you got to look at your appliance. You got to see what the center of the temperature rise is. And if you plug it into the sensible heat formula, you can calculate your airflow, right? So it's just, you just do the CFM equals the BTU output divided by 1.08 times the change in temperature. Just use the center of the temperature rise range. That'll tell you approximately what your airflow is. Then if you have a known airflow and you have a known static, you can tell what your new static will be on your duct system when you install it just by doing some fan law formulas, right? It's pretty simple. Not a lot of guys take the time to do it, but that's the secret to doing it. And what you're going to find out in most cases, the biggest problem in our industry, and I've been going over this with people is a lot in the last couple of weeks, is they're trying to fix everything at the appliance instead of looking at the system. And what I mean by that is you have a control system, your thermostat. You have an electrical system, which you need to check from the fuse box to the disconnect to the contactor, make sure all everything's tight. You've got a air filtration system. You've got an air distribution system. You've got a condensate disposal system. And you literally have to go through and look at all these subsystems that make up that main system when you're looking at doing a major change to that system, like putting in a new appliance. Because if you don't, you're doing a huge disservice to yourself, because all you're going to do is create callbacks and headaches for yourself. You're going to end up with a noisy system. You're going to end up with a dissatisfied customer. Mm-hmm. You're going to end up going back out there again because you try to do a box swap and it's something that should have been a true system swap out, right? And we see this kind of stuff all the time. because technicians are like, they're taking the easy path. But as the equipment becomes more and more complex, if we're not addressing the systems and all the subsystems, we're creating headaches, and it's a really challenging time to be in the industry, because the equipment, it's sort of like, it's like a race car. It's got to be completely dialed in to get the efficiency and longevity and capacity out of it. And if you don't have it, it's not like the old systems that you could just, you had a little bit of forgiveness in. I mean, even like evacuation, if you don't do a good evacuation and get look at the problems we've had, all that issues they had with TXVs plugging up, that wasn't because the additive Copeland put in. It was because the moisture that reacted with the additive, with the additive Copeland put in it was rust inhibitor. And now people weren't evacuating properly. Rust inhibitor reacts, clogs up the TXVs. We say it's a TXV problem, but it's really, that's just a fallout of that kind of stuff that happens. So, these are things that if we take the time and we actually address the system, then we do proper commission, we do a proper evacuation, we do a proper startup and equipment, we're going to get not only good longevity out of the equipment, but we're going to get really good performance, which at the end of the day is what the customer is paying for. So.
Just like replacing the 100,000 BTU Adam to a 60,000 the other day, right?
Oh yeah. That was actually today. Funny story. I installed a furnace almost 20 years ago at a customer's house when I was working for my dad's company, and I just replaced it today with I did 100,000 back then, and I replaced it today with a 60,000.
Crazy. Yeah.
So.
Well, I'm going through that. I put that Bosch inverter heat pump in my house, and it only puts out about 30, maybe 38,000 BTUs of heat, and obviously it turns down way down. I don't know how far down it turns, but it can go pretty far down. I bet you it goes down to maybe around 10,000 BTUs, 9,000 BTUs of heat output, and I am absolutely amazed at, we've had some 30-degree days. The heat pump carries the house just fine at 70 degrees. It just it's not even budging yet. So it'll be interesting to see how far we can turn it down, because I think not only do we oversize, but we're like way oversizing appliances.
So is it safe to say, Jim, that Nate Adams has finally gotten to you?
No, but it's he has caught my ear. No, I like Nate a lot, and part of the reason I put the heat pump in the house is to because Nate's reframed, changed around some of my thinking a little bit, especially when it comes to median temperature of a home and trying to run the equipment constantly. And I know for a fact, I had my furnace would go down to about 35,000 BTUs, but at 35,000 on a gas furnace, I'm still cycling on and I'm thinking once I hit about 50 in my house, I want the heat to be on pretty much all the time. And what I have noticed is, since I put the heat pumps been in for like maybe 20 days right now, but the house is way warmer than it's ever felt. And the other thing is, I used to set my furnace back at night. Now I just keep the heat pump. I keep it at a constant 70 degrees, but I'm not waking up anymore because the gas furnace, every time I would kick on, the temperature change was so substantial that it would wake me up. And now that I got the heat pump running, continual 70, I'm not waking up anymore. So it's interesting. And I think Nate's probably right, but I don't want him to know that yet. So.
Yeah, he doesn't watch this show anyway. You're safe.
Get out of here.
I was going to ask you too about the Bosch heat pump. Are you, because I know there was a bunch of controversy with Steve Reardon and dehumidifying issues. There's different people posting on YouTube and on Facebook about the Bosch.
Yeah.
Are you worried at all about that?
No, because I actually, so I called, we're in the same office as the TrueTech Tools. And so the Bosch rep's also the Tesla rep, and he happened to come in and say, hey, just he does a trainer. He's got it on the back of a truck. So I said, bring that thing in and let me take a look at it, because I just want to see how it runs, because I wanted to fiddle with it to see if there's stuff we could do on MeasureQuick to help with commissioning those systems. So right away, what I spent about, I don't know, maybe about 2 hours just watching the thing run. And what it does is it requires sort of a two-stage stat. So the whole thing runs off airflow. All it does is maintain a constant, like a suction pressure, right? So you dial into the coil temps 45 degrees, let's say. But what happens is let's say it goes up on the second stage, it's running a 45-degree coil, and it drops back to the first stage. Well, the inverter doesn't respond for about 16 minutes. So the thing's still running balls to the walls, but now the airflow cuts in half. And so now the coil temp drops down to like 30, 35 degrees for like 16 minutes. During that 16-minute time, the thing's dehumidifying like crazy because the coil drops way below the dew point temperature. Now, because it's doing all this dehumidification, it's not doing much sensible cooling. So the house temperature continues to rise. So now the thing kicks back up on high stage and does sensible cooling again, and then it goes back down to low stage. Now I set mine up so I've got like 3 stages of cooling, so I can drop my airflow all the way down to like 500 CFM. And at 500 CFM, and I have a 3-ton system, right? I can drop that coil temperature all the way down to, I've seen it as low as 30 degrees on a house. Wow. So, but all the jobs that Steven did, he has on a single stage stat. And Bosch sells that with the 2.0 is 2 stages, and you got to have at least 2 stages of cooling on there to make that work right. And the other guys I talked to, same thing. They use the 2-stage stat. And the trick I was telling Steven about this thing, he's like, well, I only got a single stage air handle. I'm like, just throw a relay in a box in there, and run the second stage off of a relay in a box, and all you got to do is control the fan motor, right? So just slow the fan motor down. That's going to drop the airflow down. It'll dehumidify, and then, just cycle the fan back and forth. As long as you got 2 speeds of fan, and you could pick the 2 speeds you want. I mean, it's if you got an X13 or something where you just pick the tap, it's really slick. But the reason I also not worried about it all is I have a friend of mine that's a rep down in Florida, and he's got 2 of these things. He has 0 problems maintaining humidity in his house. So I think it just came down to all control issues. And the other one I ran across was guy had it in a crawl underneath his house. Mm-hmm. And so it's just a crawl space underneath the house, and he had supply air leakage. He knew he had supply air leakage. He's like, oh, it's just dehumidifying the crawl space. Well, that's interesting, except that when you exhaust in your crawl space, then you're depressurizing the home, right? So he's got a thermostat wire running up through the wall, and in behind the thermostat, it's got these new thermostats have humidity sensors in them. So he's pulling unconditioned air up the wall through the back of the thermostat, and it's reading higher humidity than the space. And the way we found it was I told him, dude, take your 605H2, or I think he had Testo stuff, and just set it on the counter. Tell me what the humidity is. He's like, well, the humidistat must be off. And I'm like, no, I think you got a humidity issue with coming up behind the stat. What are you plugging the hole with? And he said, oh, there's nothing in there. So you put some thumb gum back in there and stops the air now from migrating behind the thermostat. And by the way, that does 2 things, because a lot of guys miss this. You should always be plugging your thermostat holes, always, because if you depressurize your house, and you'll know this because like on a 74-degree day, 75-degree day, you'll be comfortable in your house. You have your thermostat set at 74, you're comfortable. And then it goes up to like a 90-degree day, and it's just too cold. You're like, man, it's freezing in here. And then you got to bump it up to like 76 degrees. And you're going, well, it's more when it gets colder out, it's running longer, it's dehumidifying. It's all BS. What it is you're depressurizing your house. You're pulling hot air behind your thermostat. Your thermostat thinks it's hotter than it is because you got this hotter day, and it's running longer to try and satisfy the space temperature. And the space is really 72, and your thermostat's reading 76 or 78 degrees. And so plugging that hole behind the thermostat, as simple as it sounds, you would not believe it. Because I look at reports on MeasureQuick, so we have customers that take photos of everything that they do. I see it almost continuously is the biggest thing I see. And
I have a quick dumb question for you, Jim. How exactly are you depressurizing the house? I guess I'm not following that part of it.
So, okay, let's say that you have 1,000 CFM going in your return, right? Mm-hmm. And you're supplying 1,000 CFM back to the space. Agreed. Yep. So now duct works outside the space, so we're 1,000 CFM out, right? Yep. Now I have a supply air leak, 100 CFM. So I got 1,000 CFM of return coming in,
but not.
But I only have 900 coming back. So so now what happens is I'm exhausting air outside to that 100 CFM. If I'm exhausting air out, my house is going to go into negative pressure. And if my thermostat wire is communicating with an unconditioned space, or my electrical wiring or anything else, it's just going to pull down that wall. So you think about things like pocket doors in homes, and you think about, thermostat wires going down. A guy takes a 3/4 inch bit and he drills a hole to get the thermostat wire down so it's easy to pull. Mm-hmm. You're pulling air from an unconditioned wall cavity, and that's gonna cause problems. So that's why your combustion air zone also is really important to measure, because that same thing happens. Supply air leakage can cause a lot of problems.
So wait, hold on. I'm sorry, Joe.
No,
he just mentioned something that I've been wanting to talk about. So that's what you were just talking about is in MeasureQuick under CAS, right?
Yep.
Okay. So can you dive into that a little bit deeper? Because I'm, that's one of the items on there. I did watch a video on it, but I was almost thinking, which, you could steal this idea, feel free, because there's a lot of guys that are probably just as stupid as me out there. I don't know. I might be like borderline on that, but I'm just assuming so. But like certain things like that, I was never familiar with until I'm watching your videos on MeasureQuick. And I was kind of thinking if you had like a little info button next to it to explain it, because some of those, I just never knew what that CAS was. And I had watched a video, and now you're bringing it up now, and I think it's super interesting.
So I believe there is an info button in MeasureQuick for CAS testing. Let me just take a peek.
I have no idea what it is either.
I'm gonna feel real stupid if there is one.
I'm not even sure.
Yeah. So the let's see here, home, and we'll go into pressures here and see if there's a CO excess air combustion air. Maybe there's not. So let me see if there's one more capture pressure. No, there is not one for CAS testing, so you don't have to feel stupid.
All right. Cool.
But there is in MeasureQuick, I believe, under the support tab, if you dig around in there a little bit, you'll find some stuff on CAS testing. But let's talk about what that is real quick. So when you're talking about CAS testing, you can have different kinds of appliances in the space, right? CAS is combustion air zone, so you could have a 90 plus, right, and you could have an 80 plus, and you could have a natural draft. Right. So you can have forced draft, you can have induced draft, you can have natural draft. Right. What we're really concerned with is natural draft appliance, because that is the weakest appliance in the space. So most times these are like hot water tanks. Right. You go, I put a 90 plus furnace and I don't need to worry about the CAS. It's like, dude, is there a hot water tank in there? Yes, there is. So you do have to worry about the CAS testing, because, this thing about like you got a furnace in that room, you got a little return duct leakage, right? It could be in a basement, like as big of a space as a basement. And you got an open return, or you got a filter slot that's open, and but you go, well, I got a 2-pipe 90 plus, how can it be depressurizing the space? Well, imbalance of pressures in the home. So now what happens is the basement gets to such negative pressure that it overcomes the hot water tank's ability to naturally draft. And when that happens, we get spillage. And when we get spillage in a space, hopefully it's just carbon dioxide, water vapor, and heat. Nobody dies. But there are times when it becomes carbon monoxide. And when we get carbon monoxide, then we're recirculating flue gases around the house. Not a good thing to do. So the idea here when we're doing CAS testing is we are making sure that the CAS is not going so negative that it could overcome the natural draft appliances. But that said, there are CAS depressurization limits for an 80 plus furnace. There's CAS depressurization limits even for a 90 plus furnace, because those doors on those appliances are not hermetically sealed. And I've actually seen a forced draft Lochinvar, or no, the heck was it? A Viessmann boiler, huge Viessmann boiler, get overcome by a stack effect in a building. Due to an elevator shaft that they were doing some work on, and it was getting to be over 50 pascals negative in the boiler room we were at. Wow. So it was overcome. It was making the boiler go off on the pressure switch. And so these are things when we're talking about the CAS, that it can happen to almost any type of an appliance. But what you're doing is there's two things we're doing when we're doing CAS testing. One is we're setting up what they call worst case conditions. So we're going around the house and we're figuring out which rooms are pressurized and which rooms are depressurized. The rooms that are like creating a negative pressure on the communicating space, we want to leave open. The rooms are creating a positive pressure, we want to close. What we're trying to do is say, okay, if we set up everything so that it was like the absolute worst case, the dryer's running, the bathroom exhaust fans running, the doors that would be supplying air back are closed, and getting that house in like the worst condition it could, can it still naturally draft, right? And so because that's what's going to happen some days, they're going to get it in the wrong position, and now the draft's going to get overcome, and we're going to pull the flue gases back down the stack. There's some really easy things you can tell, like if you see staining around draft hoods, you see around a hot water tank, you see the little plastic rings are melted. That's because the flue gas is coming out and melting those, or staining on top of a hot water tank, or rust on top of a hot water tank. But you can't, like too many guys get, I said that furnace fixation, we're talking about looking at the system. The house is the biggest system we have, right? And you can't just walk in and get fixated on the furnace and try and fix everything in the furnace and think the furnace is working fine, because you're going to miss some big problems. And I used to, when I was teaching school, I had a furnace and a hot water tank that were twinned together, and I had what are those? A side, like a power venter on top of a metal bessus chimney that had a rheostat on. I could turn it up and down. So I get my students out there. I'm like, go check the furnace. So they're checking the furnace, and I just dial back that rheostat on there, and the furnace would actually be spilling, and the kids would like hook up their combustion analyzers and stuff, and they'd see that the pressure read positive on there, so they would just think they were wrong, and they pull the hose off and put it on the other terminal, and now it would read negative even though it's reading a positive pressure. They go through everything looking good, and they'd say, "Oh, I'm all done, Bergmann. Come over here and check this out." I'd say, "Well, yeah, you are done, because you just killed your customer." They're like, "What are you talking about, man?" I'm like, "Come over here." We go over to the hot water tank, and the furnace is running, and all the flue gas is literally just pouring out of the top of the hot water tank because the flue pipe's not venting, right? The two draft motors off the top are just pouring out. I'm like, you went through and you tested the entire thing, and you didn't even come over and look at to see if this hot water tank was spilling or not, right? You just killed your customer. And it shakes them up a little bit, because they're like, all of a sudden they realize that they got to look at other things that connect to that venting system, because all this stuff works together. And that's the kind of problems we see in our industry. Is, like I said, guys get so fixated on what they're there for, they miss opportunity. And there's nothing more expensive than missed opportunity, because it's an opportunity to either fix something or make sure we don't hurt somebody right in the process. So CAS testing is just literally making sure that we have enough air for the appliance to burn safely without backdrafting. That's all it is.
Cool.
To answer your question,
I just gotta start doing that. Do you need one of those super? Yeah. Do you need like a super sensitive manometer to be?
Yeah, you really do. We tried doing it with the Testo and the field piece manometers. We bumped out the resolution in the software a little bit to see if we could get a little bit more out of them. But the problem is they're piezoelectric sensors, so they all drift, and that means when they change in temperature, the sensor will drift a little bit. And what like Tech's got a DG8, I believe it is. It's their new compact manometer, and it's like half a blower door gauge, and it's half the cost of a blower door gauge. It's still like a $500 manometer, but it's got I think it's got half Pascal resolution on it. But what a blower door gauge does is it constantly re-zeroing. So here, going click, 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 and it's opening up the atmosphere, re-zeroing the sensor, and then measuring again, and then it re-zeros and measures again, re-zeros and measures again. It's the only way you can get that kind of resolution. And resolution means how much you can resolve. It means how small of a change you can detect is resolution, versus accuracy, which is how close it is to the actual pressure you're reading. You need to be able to resolve very small changes of pressure, and that's what a blower door gauge does, or a DG. I think it's the DG8 is what that is.
Yep.
That's a great little manometer, but it's expensive, but it's just one of those tools that you should have if you're going to work in the HVAC industry.
But that comes in the new TrueFlow grid kit. It comes together. You buy them together.
Yeah, and the TrueFlow has also got its own manometer built in, so it's you actually are getting 2 manometers in that. That TrueFlow actually been tested in our shop. It's pretty slick. It's
sweet.
It's a nice little product. So I think that's going to be the nice thing about it is it's so fast to measure airflow. And I use it a lot in my shop because we're testing like our airflow, estimated airflow calculations and things like that. Every once in a while, I get a piece of equipment where it doesn't work like it's spec'd. It'll have like lower airflow or higher airflow, and we're thinking there's an issue with our calculation. So I can grab that TrueFlow, throw it in, and see what the heck's going on. And it's actually, I think, a little bit better accuracy than it's. I think the TrueFlow used to say it was like plus or minus 7%. I think they're dialing it in, so it's even a little bit better than that now. So it's a pretty good product. It's a really good product, and it's way easier to use without all those hoses. I mean, you literally just drop it in the return here. Yeah, and you got to measure it. It probably takes like a minute and a half, 2 minutes to get a measurement off. Get a full airflow measurement off that. So,
well, there's 2 guys here that are going to grab it right away as soon as it comes out. That's for sure.
Yeah. Steve's done a really good job with that. So it's a cool product.
Now we're talking about ducts. The one thing I want to mention was in quick test mode, the duct leakage calculation. Summer's coming up, and I always hear it. I'm not getting enough this upstairs. I think I have leaks in my duct. Yada yada yada. Is this handy for applications or houses that don't have, let's say, a return or supply, or let's say they're all in conditioned space, or not in the attic or not in crawl space? Is it still handy to do a duct leakage test?
Oh yeah. I mean, it's there's 2 things it does. One is duct leakage, and the other one is capacity loss, right? Because there's 2 things that are happening there, right? We can get like just heat gain from being ductwork running through an attic, right?
Absolutely.
And you can so what MeasureQuick does is it's a screening. It's just like you used to set up on a mixed air and economizer, where you measure the outdoor air temperature, you measure the supply air temperature, you measure the return air temperature, and uses mixed air formulas to calculate the leakage. Now, what's different on the MeasureQuick calculation is, number one, you want to use 2 sensors when you're doing. You want to have 1 sensor on each side of the fan inlet, because the air, if you have a duct leakage, it'll tend to like laminarly flow up one side of the blower or the other. So unless you're measuring on both sides in the volute, on the inlet to the fan where the air is turning and mixing, you may miss duct leakage. So you want to have 1 in supply, 2 at the fan, 1 on each side of the fan inlet, and then 1 in the return. And the return one's literally the face of the return air grill, right? And then what you do in MeasureQuick is you enter in your return air. If it's an unconditioned space, you would want to enter in that whether you have a square or round duct, the diameter of the duct, the length of the duct, the R value of the insulation. It'll run the calculation, and it'll tell you. And also it measures supply air static at the same time. So what it does is or maybe it's return air static or total. I can't remember right off the top of my head. But what it does is it then normalizes that for 25 pascals, because our industry standard for like a duct leakage test is what's my leakage at 25 pascals of pressure. So in MeasureQuick, what we do is, because you're using your blower, which is running like 1/2 inch of static pressure, then we normalize that and tell you what that leakage is at 25 pascals, and also what your leakage is and what your loss is, your BTUs and loss is, so that you can see, maybe you're picking up a lot of heat from the duct and you need more insulation on the return because it's running through a hot attic or whatever. So it does both, and it's actually very accurate, surprisingly accurate, and it's using just basic science we've used in our industry forever to set up an economizer. I mean, it's nothing magic about it. It just does all the calculations for you.
So basically, you need at least three sensors if you don't have attic.
Yeah, I would do 4. So I do, like I said, supply air, because what we're doing our estimated airflow calculation.
Yeah.
So if you put it into cooling, the big thing the big problem with leakage is actually return air leakage when you're looking at most systems, because the way people build return air chases, and they have decking and stuff that they're pulling air through, but when you're pulling in 130 degree air from the attic, like in southern climates, that really erodes your capacity really quickly. Yeah. So That's what we're primarily looking for. Now, MeasureQuick cannot measure supplier leakage. You need a duct blaster to do that.
Okay.
But returns are where most of the problems are actually show up.
Sure. All right. Adam, do you have anything also not on the duct leakage?
No, not on the duct leakage, but speaking of pressure, I did notice, I'm kind of going through, I'm finding new sections that I've never seen before in MeasureQuick. I was using MeasureQuick for a while, but kind of just like basic, turn it on, turn your probes on, superheat, subcooling, that's what it is. And there was a couple of circumstances where I did the full workup with BTU output and everything like that for a few systems. But I've noticed sections I've never saw before, especially like the furnace, where you're measuring inducer pressure.
Yeah.
And so what is that actually? What is that doing?
So you got a pressure switch, right?
Right.
And your pressure switch is, let's say it's set at 1.2 inches or 0.5 inches or 0.7, whatever it is, right? You don't want to be in a threshold of what that pressure switch is going to cut out, or it's going to flutter. So you want to be about 2 times what the pressure switch setting is at. So your induced draft pressure, like if your pressure switch is set at 1 inch, you should be pulling about 2 inches on a negative pressure switch on there. So what we're doing is just when you're going through the profile and you tell us, hey, here's my pressure switch reading, right? And we measure your induced draft pressure. It's telling you, is it getting too close to that threshold where you're going to have an issue, right? The other thing you got to watch, and the other reason you should always watch, a lot of guys don't watch it and they don't understand why it's so important, is if you have a 90 plus furnace and you have water backing up in the secondary heat exchanger because it's not properly trapped. The reason we have to have a trap on a 90 plus is because the induced draft pressure is pulling a negative, right? It's pulling, it's sucking on the heat exchanger. Yeah. So if it doesn't have a trap on there, it's pulling the water up backwards. So whenever you shut off a 90 plus, if it starts pouring water out, that's a big problem, right? Yeah. Because it's overcoming the trap and it's pulling air up. So what happens is it runs for a long time and that water can't drain out, is that it starts blocking the secondary heat exchanger. And then you start losing your secondary air that goes into your burner. Your primary air goes through your burner, secondary air goes in around the heat exchanger. When you start choking off that secondary air, you start making massive amounts of CO. Bill Spohn and I went out, we did a expert witness case probably 10 years ago now, 8 years ago. And we caught water backing up in the secondary heat exchanger on an appliance. It got up to 17,000 parts per million before we stopped the measurement. Wow. I mean, so what'll happen is it'll run fine, and you start seeing it creep up, and then it's like a hockey stick. It just goes through the roof because all of a sudden you hit this threshold where you don't have enough oxygen to support all the carbon in the fuel, and then it just goes crazy. When you're talking parts per million, it doesn't take a lot of change for that to happen. So we're doing a couple things by watching that induced draft pressure. We're making sure that it's not, we're making sure that you have enough and that it's not dropping off, right? So when I'm looking at that gauge all the time, what I want to see is once it's up there, it holds up there. And, things can happen like to your bearings on your induced draft motor. They're going bad. As the motor runs, it heats up. A lot of times you might identify that with your amp draw, your meter. Like you throw an amp clamp on there, you see the amps climbing on an induced draft motor as it's starting to seize up. But the other way to test it is through watching the induced draft pressure. As it seizes up, it slows the fan down. As it slows the fan down, the induced draft pressure starts to drop until it shuts off on the pressure switch. So that's why we watch that reading.
Cool.
Adam, did you want to go through? I'm saying Adam because I don't think Bill has done this with the blue flame. Anything with the blue flame, like
none of this,
setting up the profile or anything like that?
So the blue flame. Oh, I had questions about. There was what was it now? I did not. You caught me off guard a little bit, I think.
It is cooling season. We could talk about the blue flame, but
yeah,
you're right.
You guys are. I know the Canadians up there still think it's winter time, but
I still have it going. Something just like you guys. Listen, we're not too far off. Yeah.
But you really, seriously though, you should be using your combustion analyzer year round. A lot of guys,
Absolutely.
they're like, I don't need a combustion analyzer because I don't work on that many furnaces. And it's like, if you work in a home where there's a gas meter attached to that house, you need a combustion analyzer, period.
Listen.
And you need to be using that thing year round, because the hot water tank runs year round. The gas furnace runs, or gas stove runs year round. The gas dryer runs year round. And guess what? Your sensors are going bad in that thing, whether you use it or not. If you buy a combustion analyzer and you set it on your shelf, a year later, it needs calibration, period.
Yeah.
It just needs it, because they're chemical sensors. The chemical sensors are always absorbing oxygen out of the air. They go bad. You can't stop it. From the day you buy it, it's the only product you buy and it's going bad, whether you use it or not.
Right.
But it's just part of the maintenance. You just got to send it in once a year, get it calibrated. Sometimes you need to get new cells in it. But the thing is you can't overuse it. You're not going to wear it out by using it. It's going to wear out whether you use it or not, because the cells, it's just like a smoke detector in your house. And that lasts for 5 years. You got to buy a new one, right? Because the chemical eventually expires in there. So important thing to know.
Up here, it's cold. If I show up to a house and I see a natural drafted boiler, I have to do a combustion test on it. It's by code here, no matter what,
The one I was going to say, the measurement, I just thought about it when you were saying outside air. I'm actually thinking on the Blue Flame, and you look at a MeasureQuick report, there's a spot that shows outside air. And I was wondering, because I've been used to using the Backrack Insight Plus, and I picked up the Blue Flame to try to use and, directly with, I know I could use the Backrack as well too, but I don't know. I just like buying tools. I'm stupid like that.
So the reason we're measuring outside air, I believe, is we're also calculating the draft pressure. So when you're looking at natural draft, as the outdoor air temperature goes down, the natural draft increases. So there's actually a formula that tells you, based on your outdoor air temperature and your indoor air temperature, what the amount of draft and the minimum amount of draft you should have. So like on a 90-degree day, you might have almost no draft. And on a 0-degree day, you have a lot of draft, right? So MeasureQuick is just doing a calculation in the background based upon that outdoor air temperature, because remember, we're calculating targets for everything, right? What that draft pressure should be. So I believe that's what we're doing with the outdoor air temperature for that. And the other thing we do it for is just so we get an idea of just environmental conditions, like for air conditioning tune-ups or gas furnace tune-ups. What was the weather when you were doing the check, right? So, but I believe we are using that in the gas to calculate the draft pressure.
Cool. Got to start. I'm trying to fill all the blanks. You know what I mean?
Yeah.
And that was kind of another thing too. When you're using MeasureQuick, is there like certain things that you have to, if you're gonna benchmark a system, that you really should be filling out, and other things where it's like, well, maybe you don't necessarily need all the measurements. You know what I mean? Like,
so that's a good question, and we get that a lot, and it's like, if you think about most air conditioning systems, there's only two things you can really set. It's refrigerant charge and airflow, right? Everything else is sort of engineered. Right now, obviously, we want to do a proper evacuation. That's critical because we don't want to have any non-condensables in the system. But just, once we get the evacuation done, we're talking about the big two things there are charge and airflow, right? Now, when a benchmark, a lot of people don't understand what a benchmark is. And a benchmark is actually like capturing the personality of the equipment. Like, let's say you got two 2-ton systems sitting side by side, right? One's got a 50-foot line set. One's got a 150-foot line set. One of them's going up, up the side of the house, 20 feet before it goes into the attic. The other one's popping right through the basement, and it's no lift at all. One of them's got all the ductwork in a conditioned space. The other one's got in an unconditioned space. One of them's got a 16 by 25 filter. The other's got a 16 by 20 filter, right? Whatever it is, they're different, right? But even though the equipment's identical, that equipment its operation is going to be a function of its installation. So when you're doing a profile in MeasureQuick, right, we're saying best guess, right? Based on what you're telling us, it's 410A, it's a 13 SEER, it's got a target superheat of 10, it's got a target subcooling of 6, whatever it is. MeasureQuick's looking at that saying, okay, here's how we're thinking it should run, right? So the big thing you don't want to get fixated on is really what your pressures are, like your high and your low pressure, because there's targets for those. And we're saying here's about where your target should be. But it really comes down to, your line set length is a big factor in there. Because if you have a really long line set, you're going to have a lot of pressure drop in the suction line before it gets to your compressor. You might drop 2 or 3 PSI in the suction line. You may drop more on there. And that actually comes with the capacity loss in the machine. You can actually lose, anywhere from 1 to 8% of your capacity by having a really long suction line on the machine. And so pressures are the one thing I don't fixate over. What I really fixate on MeasureQuick is either my subcooling or my superheat target, right? Because that tells me I got my right amount of refrigerant, my evaporator, my condenser. And I always look at both sides of the system, period. I want to make sure I have enough subcooling, that I get a liquid seals for my condenser, and I have the correct amount of, a reasonable amount of superheat. Even on TXV systems, really important. I just was working with a contractor the other day. He put everything together. He's running like 2 degrees of superheat. I said, well, did you check the TXV bulb? He's like, yeah, you couldn't pull it off if you hooked it to a trailer hitch. I'm like, did you insulate it? He's like, no, don't need insulated. It's in the supplier stream. I'm like, do me a favor, dude, just insulate the bulb. So he goes and he puts, some foam insulation around the bulb. All of a sudden the superheat goes up to like 6-8 degrees of superheat. And I said, well, the bulb works off 2 things, right? It works off of it's basically it's driven off temperature, right? And we got an external equalizer that's looking at pressure. So what's happening is your bulb is getting warm, and it's picking up heat, and it's overfeeding it's overfeeding. So just putting some foam around that thing, and insulating the bulb took care of the problem. And these are things that if you're not looking at both sides of the system, you're going to miss. Now the other one is really important is airflow, because airflow is going to dictate how much cooling you do versus dehumidification, right? And we always want to be above 300 CFM per ton. If you drop below 350, you're not gaining any additional dehumidification capacity. What a lot of guys don't realize is that latent load is reserve load. So you're never going to do latent cooling unless your coil falls below the dew point temperature. So if you set up that equipment and you shift the latent sensible split, like let's say it's at 400 CFM, it's a 0.75, and you drop it down to 300. Let's say it goes down to 0.68. I don't know, some kind of shift in there. You just said, hey, I'm gonna give it additional latent capacity, and I'm gonna sacrifice my sensible. Yeah. So what's gonna happen is your equipment is gonna run longer to satisfy the sensible load. And everybody goes, well, it's dehumidifying more. Well, no, it's not. Not if it's not dropping below the dew point temperature. So like low airflow in Arizona just robs the system of capacity, period. Right now, if you're where Brian Orr's at in Florida, they actually have a substantial amount of latent and sensible, and they tend to have really large systems. Like they'll go to a 5-ton system, but then they'll throttle it way back on the airflow so they can get the dehumidification because they're dealing with a lot of heat and humidity, right? So they do run their systems at 350 CFM per ton. But Arizona, they want to be at 450 CFM per ton. Ohio, 400 CFM per ton. So I pay really close attention to where my airflow is set on the machine. And, and then the other piece of that, when you're watching airflow, is you're also watching your static pressure, because and you're going to see a lot of these ECMs, they are, once you get about 0.7 inches of static and a total external static, the ECM just starts falling off, right? It just can't do the work anymore. And so you end up with ECM drawing a lot more amp draw and not producing a lot more usable work. And then you get what's called a high fan watt draw, which means you're using a lot of watts per CFM air you're moving. And so you get big efficiency loss in the system, right? Those are things I look at. And so once I get the charge dialed in, the airflow dialed in, I look at my pressures, make sure they're reasonable, and then I benchmark the system, and that sort of locks the pressure targets, and those pressure targets are actually design temperature differences. So it's how much colder the evaporator is than the return air, and how much hotter the condenser is in the outdoor air, right? And the thing is you got to make an educated guess. But like if you took a Lennox, I've seen some of this new Train and some of the new Lennox and some of the new Goodman stuff that is running a 10-degree DTD, right? They got the huge condensers, and they run these really low DTDs, design temperature difference, or CTOA, condensing temp over ambient. So they do that because they have remember, BTUs are a quantity of heat. So if we're going to reject the same quantity of heat at a lower temperature difference, we need a larger surface area to reject the heat. And then we go like an old 6-SEER, right? We have a really small coil, but a really high temperature difference. So it can also reject the same quantity of heat, but it does that at a higher head pressure. So it's all about balance. And once you get the system balanced out, then we benchmark it so that what that does is really cool with benchmarking is we know exactly what the pressure should be compared to the load. So we know if we're starting to, the condenser's starting to get dirty or foul or things like that, because now we're not, instead of an educated guess where the head pressure should be, I know exactly where it should be. So now the diagnostics and MeasureQuick become exponentially more accurate because we've optimized the system, we've captured its personality in the benchmark, and now everybody that goes out is using that same tribal knowledge about how that system is supposed to work to make their assessment of what's wrong with it. That's the name of the game right there. So go ahead.
Oh, you know what? I was just going to say, Adam, for someone like you that has, I forget his name. What was his name, Bill? His employee? Who's just learning?
Johnny Wang.
Yes. It's great for him because that's a good stepping stone for him. Somebody just, get out of school or just, they don't have to go so in depth. They could just, let's say, charge a unit just by, since it's benchmarked already, by what's called non-invasive testing or whatever.
Yeah, and we do a lot too. We have a lot of our bigger customers. The big thing that they do is data streaming, and so they have a lot of installation crews. The installation crews are installers is where a lot of guys start out because they know that they know how to do the mechanics of things. They know how to hook up the line set, hook up the wiring, hook up the thermostat, but they're not skilled in diagnostics yet.
Right.
So we ran across one just the other day. Had a contractor I was doing some training with, and he's like, hey, there's one of my techs streaming data. Let's look at it right now. So I looked at it and I'm like, whoa, this is really weird. MeasureQuick's picking up, it's got a missing metering device, but the pressures don't make any sense. So I go in and when you're streaming data, you can actually go in and see what the model numbers and serial numbers of the equipment. So I look at it and he's got a 3-ton condenser and he's got a 2.5-ton air handler. And I'm like, well, there's your problem. But I couldn't figure out what the heck was going on with the metering device. And so I'm driving home and I'm thinking, I called the guy back and I said, hey, you guys are using pistons for metering devices, aren't you? And he goes, yeah, that's what we use on a lot of these units. They're Goodman units, so they come with a piston in them. I said, well, does that piston come in the bag? He goes, yeah, it comes in the condenser. The guy's got to put it in the evaporator coil. I said, well, you better tell that guy that's swapping out the air handler, he's also got to swap the piston out again because he put an oversized piston and an undersized evaporator coil. Software picked it up. MeasureQuick picked it up. I didn't even get it myself. I've been doing this for years. It caught me off guard because I didn't think about, because I'm so used to TXVs now, I didn't think about somebody actually throwing the wrong metering device in an undersized evaporator coil.
So what size did he put in? He put the 3-ton in it?
He put the 3-ton piston in a 2.5-ton evaporator.
So it was that flooding back then?
Yeah, MeasureQuick picked up the piston was either oversized or missing.
Okay.
Because it's a 3-ton piston so you got an oversized condenser, undersized coil, and oversized metering device, and the software picked it up. But I was looking at it and it just wasn't registering. It just didn't make sense. But it's because I didn't have the intel to know that it was a piston, because the guy actually profiled it with a TXV. He didn't go through and change the metering device. So I thought it was a TXV, and then as we're chatting with the guy, I find out it's a piston. So. But those are the kind of things when you stream data that you go, the installer wasn't very happy because he had 4 systems he was putting in and he swapped around 2 of the air handlers by accident. Mm-hmm. He was a little torqued off, but for the company, now they've catch it. Yeah, they caught it. They're not going to have equipment failure. They're not going to have a dissatisfied customer. You got an irritated installer because the guy's got 20 years experience. And he just made a simple mistake, but they just think about just the social media outlash they're going to get from a customer that they spend top dollar for a system and it doesn't work right? So those kind of potential problems are averted. But it literally takes us, if you stream data, you can look at a system, and within the 5 minutes, I usually look at the superheat, I look at the subcooling, I look at the total external static pressure, I look at the sensible capacity to make sure it's 95% or higher, right? I look at the fan watt draw, and if those things fall in line, it's good to go, right? And those are the things I'm always looking at when I just skim through a report. And then I'm also looking at like condenser watts and evaporator fan watts, because I see sometimes people either get them reversed or they measure the same one twice. So they'll measure inside unit for both condenser and evaporator because they're not paying attention. But those are the things we look at when we're like evaluating those reports. So
nice. So did you end up with your Bosch system? Were you able to come up with something that MeasureQuick can do with an inverter? Like, are you looking at starting to work with inverters in the future?
Yeah, we're looking at some ideas because the inverters are really, they're quite interesting. I honestly think it's going to be the future of HVAC because, if you look at that Bosch unit, you just reduced basically 8 SKUs down to 2. Right? Because you got, 1.5 tons, 2, 2.5, 3, 3.5, 4, 4.5, or 4 and 5 ton. Right? So, I mean, and you could just sell a heat pump. I mean, I bust Nate's balls all the time, but I do respect the guy. He's really, really, I think, brought a lot of awareness to how good heat pumps can actually heat homes. Because when I was growing up, my dad was like, yeah, you never want to put a heat pump in they're cold, they're miserable. But it's because back then they didn't know how to do like defrost cycles. They didn't pull in, there's a lot of stuff. Today, it's actually amazing how good the heat is. I'll just tell you that straight up. I'm amazed that it actually works as good as it does. But the thing is that after putting the heat pump in, I don't think I'd ever sell anybody an air conditioner anymore.
Damn.
As far as I'm concerned, I think that you just get rid of air conditioners altogether and just the only thing we should have is heat pumps, because it doesn't make sense to sell. I don't care what climate zone you're in, even Brian Orr needs heating once in a while, right? I mean, even he's down almost in Miami down there, they still need heat once in a while. So, and you guys in Canada, you need heat. How many mild days do you guys get in Canada? I mean, your summers are pretty much our mild days in Ohio. You guys probably.
I'm right across the border. I'm not that cold.
Not that cold, but it does.
I hear you. What you're saying.
It does make a lot of sense to have one appliance that's doing both. The thing that Nate's got going for him right now is electric costs are really, really low. I mean, and so it does make sense, to use the heat pump, and it actually makes sense to use it down to fairly low temperatures because they're doing pretty good. They got pretty high COPs, so it's interesting. But as far as MeasureQuick goes, the way these inverters are running, we're seeing a lot of different ways that they run. So we're almost going to have to write some custom programming for like a Bosch unit versus a Train versus, the really hard ones for us to do right now, and actually for the entire industry to do, are the built up VRF systems where you got multi heads. Because I don't know, the only way to properly charge those if they lose gas is to pull all the gas out and weigh the gas back in, because you just can't. You can't charge it by superheater subcooling. There's just no way to do it. It's impossible. So those are going to be, I think, a big pain in the butt for the entire industry. But the inverter stuff we'll be able to figure out. It's just understanding the different characteristics of inverters, and there's like no industry standard right now on how that stuff is. It's all proprietary. It's all unique to these companies. So.
Now, Joe keeps telling me to ask questions because he doesn't want to talk for some reason. I think he's bashful tonight or whatnot. But I think this was kind of where we ended the last time you were on. Was Hoser HVAC is pleading with you to reconsider a monthly subscription because he has a company that he works for that does not. They're too big, or the owners don't want to pay for it. And I guess he wants to pay for it out of his own pocket.
We have lamented. It's probably been the most challenging thing for us, is trying to figure out how we want to monetize MeasureQuick, because you have a lot of people, like if we just put a price on the reporting and said, okay, this is what we're going to do, they're just going to say, well, that's good enough for me. This is what I want. And then they're not going to use MeasureQuick to its full potential. And the thing is that what people don't realize is MeasureQuick is free. It's literally free. It's like you're saying, well, how much should we budget for capacitors this year? Who gives a damn? You're selling them to your customer, right? You don't sit down and go, what's my overhead cost for capacitors? You do that with, with your cell phone bills and your truck, what your fleet's going to cost you. With MeasureQuick, we set it up. The way that's set up is designed that you pass it through the cost to your customer. You can mark it up. You can pass it through $5 to the customer, but we're storing information about their system that's a benefit to their customer. We're doing a third-party diagnostic, which is a benefit to the customer. We're handing them a report, which is a benefit to their customer, so they got some documentation. We're storing that data in the cloud so they get consistent service going forward. And we're giving them a means for non-invasive testing, right? But it doesn't cost the company anything if they pass it through. And we looked at doing like a monthly subscription and stuff, but a monthly subscription becomes an overhead cost. When I just design an iManifold, we tell people it was like, $49 a month. And they're like, well, I only use it in the summer. I don't want to pay for that in the wintertime because I'm not using it. And it's like, what's going to happen to my cloud data if I don't pay for it? And, all this stuff. It's like, it's really tough because we're trying to engineer a solution to fix the industry. And you get people that want to use, and we want to give a lot away for free and the reason we do this is because we want techs to be able to, to do their jobs better, to leverage their tools fully. I mean, we give way too much away for free. And the challenge becomes when you go to monetize it, you can never make anybody happy. And we've tried over and over to figure out what that's going to look like because, obviously we've got a huge investment, millions of dollars actually in programming. We've been doing this for 3 years now. And, when we do programming, our team's been as big as 19 people. Now it's, I think, about 7 or 8 people doing the programming, when we started, but programmers aren't cheap. We hire all our guys are stateside. They're all employees that work for MeasureQuick. We don't do any outside programming. So those are all like real employees with real benefits. It's like, this is a legit, company we're running here. Absolutely. And so, but I've always had a real passion for trying to help people and help them do their jobs better and give them as many tools as we can. And so, we're just trying to figure out I've engineered this whole solution. Now, how can I get people to actually use it? And it's very frustrating sometimes because it's like we could have 7 out of 10 systems have charge and airflow problems. 7 out of 10 across. I can show you 2 or 3 studies today that were done in the last couple of years. That 70 to 100% of systems have charge and airflow and duct leakage issues. Period. You got to ask yourself: are your guys finding them that way, or are they leaving them that way? Right? Because if you're not finding airflow, charge, and duct leakage issues on 70 to 100% of the systems you service, you're leaving money on the table. And the guys that go out there and they're mechanics, they go out there to see capacitors burned out. They go out there and they're charging $200, $300 to change a capacitor out, and they're not looking at the control system, the electrical system, the air distribution system, the duct system, the condensate disposal system. They're just going out and changing a capacitor. They're doing a disservice to them, to their company. Because I'll tell you right now, it costs your company $100 to $150 just to get to that customer in marketing and advertising dollars. And he just went out there and did a $200 or $300 job that where you could have offered your customer a $2,000 or $3,000 opportunity to actually fix the problems that exist in their house. And had you offered it to them, they likely would have entertained at least part of that repair because they know they have issues, but nobody knows. It's like going to your doctor. Think about what we do as an industry. We have guys that go out and they literally write down the readings that they know the boss will accept. They write down, 118, 10 degrees of superheat, 10 degrees of subcooling. Imagine if you went to your doctor and the nurse just stood outside and wrote your blood pressure down, your weight, and your temperature down in your chart. Just, and the doctor came and said, you're perfectly healthy, but then, you freaking die from an infection the next morning, right? Somebody's head would roll. In our industry, we just don't have anybody that's policing us. So we got to sort of police ourselves. But the problem is that if you don't take control, think about what MeasureQuick does for you and your company is it takes control of the measurements. It's like the one thing you don't have any visibility into as an owner of a company is what your techs are doing. Do they have the right tools? Are they using those tools? Are they putting the pros in the right location? Are they using that data to actually make an assessment of how that equipment's performing? Are they doing diagnostics with it? Or are they just writing down a bunch of BS because they don't know any better, right? So it does provide some accountability for technicians, and it will make them better. If you start using MeasureQuick on a regular basis, you will be a better tech in a couple of weeks because you're going to see relationships you've never got to see before. But additionally, you're going to find problems that people have overlooked for years, and just because they just didn't even know they existed. And MeasureQuick will pick up things like duct leakage, missing metering devices, wrong size meter. It does 150 different problems. It's going to find something wrong with almost every system you touch. And if you're not finding those things and you're just changing the cap out, you're leaving a huge amount of opportunity for your company on the table. So when you look at what does that cost you, and people say, well, first thing that everybody does when I tell them it's $5 per system per year, they go, well, we
but
do.
It's, hold on a second. That's a little bit not true. That's what my misconception was last time. It's not actually, well, maybe it is true, but I talked to one of you guys at your office and I asked him $5 per system per year if you use it. If you don't go back to that system for 2 years, you're not paying another $5 until you go back to the system.
That's correct. Yeah. We'll store the data for you indefinitely, right? So it's just that once a project's open, though, it's open for the year. So like let's say you wanted to train your techs at your company and you had 2 systems that you had MeasureQuick on. You could train 100 techs. You could stream data 24 hours a day. You could do a bazillion reports, and it's not going to charge you anything but $5 for the year for that system, right? That's how it's built.
Right. So like that was one thing that kind of scared me from signing up with it earlier on, because I thought, well, I have right now, I mean, I'm kind of a young company. I don't have a lot of guys, whatever, but I have 1,500 customers. And I'm thinking, well, if I have new customers and I start adding these, 1,400 eventually times $5 a year, that's a lot, but you're really not seeing 1,400 customers a year.
Right. Well, the thing is too, is you're only billing your customer for MeasureQuick when you go out there and use it.
Right.
Right. And it literally is like I said, it's like a capacitor. It's a pass-through. It's what we call an operational cost, not an overhead cost. Right. Operational costs are the consumables that you use and sell to your customer. You don't budget your furnaces for the year. You don't budget your capacitors for the year. You don't budget your wire ties for the year. You just, those are things you bill for. But you do budget what you're going to pay for trucks, what your rent's going to be for your building, because those are things that are overhead costs to your company. So we really focused on making MeasureQuick an operational cost versus an overhead cost, so that the person that's benefiting from it, your customer, is actually one that's paying for it instead of taking money out of your pocket. And if you use it right, it's going to not only save you a ton of time, but it's gonna pay for itself 10 times over in found opportunities and reduced callbacks. Because the other thing you got to remember, what's a callback cost you? You got opportunity loss, right? Because you could be making money somewhere else, but then you got to pay all the overhead costs to your company. You got to pay for the wages, the uniforms, the insurance on your trucks, the truck payment. So for every hour, if you take all your overhead costs and you add them together, right? That's the minimum your company's got to bring in per hour. You add them together and just do a little bit of basic math there. You got to figure out how much does it cost me per hour to run my company, right? And that's just your break even. So whenever you have a callback, you not only have the opportunity losses, but you have the overhead costs. So it ends up costing a typical company $400 to $1,000 an hour in overall cost. So just take one callback a week and divide it by 5. Right? MeasureQuick is paid for. Even if you paid for it, it's paid for the month. But if you're not paying for it, your customer's paying for it. And that's why we set it up that way. It really, but people just, for whatever reason, they just don't get it yet. We get some customers that they get it and it's like, this is not a problem. This is a no brainer. They're going to, that's what they want to do. Other customers, they just can't wrap their mind around it yet. So it's been a challenge.
I think it might be you're getting a lot of the techs that are curious and that are on the internet researching it. They're sold on it, but maybe they're the owners of their company. or whatever. Their bosses are not quite sold on it.
You get a lot of, I mean, it's, I don't know. It's, again, it's people not understanding
the benefit,
the benefits of it. And, I don't know. We're seeing a larger and larger adoption of people, and we have a huge number of people that are using MeasureQuick. But as we're trying to add more and more features in, improve the diagnostics, tie it into more CRMs, it's like we definitely want to start growing our user base faster. And so when we're looking at trying to like parse out features of it and sell those features individually, that might completely erode our model for actually being, for long term, for the long term,
I could see that.
So it's, but yeah, we're always trying to figure out, different ways to, that we could skin the cat, but we've been working at it for 4 years, and this is about the only way we can see that it's like long-term sustainable. And we're doing something nobody's ever done before. I mean, nobody's ever, we didn't have Bluetooth tools 10 years ago, so, and nobody's thought about really taking control of measurements like we're taking control, but this is a big hole in people's buckets. They just don't realize it. In fact, I challenge you guys that are business owners, Monday, have all your service techs come in and just say, hey, we're starting cooling season. I want you to bring in all your stuff, all your tools, so we can just do a little inspection to see what tools you have for charging air conditioning systems. I want to see your gauges. I want to see your thermometers. I want to see your vacuum pumps. I want to see your micron gauges. I want to see your hoses. I will guarantee you'll have somebody in your company that does not have a thermometer. You'll have somebody that has one suction gauge or one high side gauge. And they're going to tell you, well, the other gauge broken. I just haven't got it changed yet. You're going to have somebody that's got a set of gauges that looks like they're from 1973, that are just beat to crap. And then take your guys and have them bleed the pressure out of their gauges that are using analog gauges and see where the needles rise. They're going to be sitting at 5 pounds, 10 pounds in a vacuum when they're not in a vacuum, right? You're going to have guys that, and if you even want to have more fun, set a window air conditioner up in your office and have 18 or 20 guys measure superheat. Just leave one set of gauges on it and have everybody use their thermometer to measure superheat on that unit. Now, the superheat's not going to change because it's sitting in your giant shop and it's not doing anything. And see how many different answers you get for superheat, right? Because I guarantee you have guys that can't measure superheat. You have some guy take his K-type thermocouple bulb and touch it to the suction line. You have another guy with a clamp that clamps it on. You have another guy that does it another way. You have another guy that tapes it on, and they're all going to come up with different answers.
I like the laser one.
Yeah, the laser thermometer. So if your guys if you can't get 19 guys to give you the same superheat reading, how are you ever going to get any consistency to the outcome of your work in your company? Right? I mean, we got to be plus or minus 3 degrees of subcooling. Some of the Goodman stuff, plus or minus 1 degree of subcooling, right? I'm seeing really on like microchannel and stuff like that. How are we gonna get it done? So it's a challenge.
Well, Bill fell asleep.
Yeah. No.
Poor he's in chat.
Yeah.
Well, I think it's we're half hour over our time. I think it's a good time.
Yeah. Sorry, guys. I didn't.
No, it's not. Don't be sorry. You're doing amazing.
No, it's very interesting. I could sit here and talk to you all night long.
Well, is anybody else? I mean, if there's any questions, I've been seeing a bunch of stuff blow past chat here, but
first of all, I want to clarify something. You just had this heat pump for how many days?
About 20 days.
Okay, so we didn't go through a hard winter with it.
No, but I got a gas furnace for that.
And he has a gas furnace, guys, in chat. Trust me, he has gas still. He's you need gas still.
I've got a pellet stove too, just in case the gas furnace and the heat pump go out.
I know you're going to start. I know you're going to find the exact balance point where the temperature is going to slip.
Well, that's where I'm trying. That's why I turned it all the way down to 20 to see if it'll maintain down to 20. So far, I've gotten down in the high 20s, and it's been perfect so far. It's been. Well, the thing that's sort of weird, and that's what I didn't appreciate it till Nate. In fact, actually, I listened to Nate, and it sort of blew off the whole median reading temperature, and like, oh, that's really interesting. But until you experience comfort, you really don't have an appreciation for it.
That's what it is, comfort.
Yeah, it is a comfort. And it's actually, I can tell you in my house, I've only experienced comfort a few days a year. I've experienced comfort for the last 20 days. Like I walk in and I'm not getting a blanket. I'm not, getting my slippers on because my feet are cold. The whole house is actually like this. In fact, I got a thermal imager from TrueTech. I borrowed it, and I'm like, I have the most boring thermal image pictures in my entire world because everything's the same temperature, right? Except for my windows. My windows I can see, but literally the carpeting, the walls, the furniture, everything's just sort of bland because it's all the same temperature. And so that heat pump, because it's running almost continuously, everything just gets to like this level of warmth, and it just sort of stays there. So it's not cycling, and just eliminating those cycles, it's amazing how much more comfortable the house got. So, I just don't want to admit it yet because I gave Nate such a hard time for last several years, but it is amazing how much more comfortable it is in the house. It's very interesting.
Guys, if you have any questions, please put them in the chat. ADH is saying mine runs down to 20 and holds the home just fine in Denver.
Yeah. Yep. I saw one on there too, by the way. Somebody was asking about true blue hoses popping apart because I do the training for AccuTools, and just to address that, they actually had the fittings have a snap ring in them. So it's like they actually improved the design because they eliminated the braze so they could machine one piece of it. Then they could open up the throat a little bit more. And when the outside of it's got a swivel nut, and then it's got a snap ring. And so it's pressed on, the snap ring snaps into a retention groove. Well, the company that made them, after they machined them, they didn't run them through a parts washer. Somebody grabbed the parts bin, and there was probably about 250 pieces of brass that did not get properly cleaned. So they put the stuff into kits, and like if you've ever been at TrueTech, they literally get 250 kits in and 250 kits go out. So these all went out into the marketplace, and they're 1/2 and 3/8 fittings, and they're popping apart. And if you have a fitting pop apart, just call AccuTools and they will give you another fitting. They'll mail it to you, and pretty much no questions asked. They'll take care of you because they should not pop apart ever. So they're taking care of it, but it was a very annoying thing for all of us just because they're super quality conscious. So but they're fixing it. So it's fixed, and they're replacing the parts.
Well, I'm going to ask one last question. I know this is for Chris because Chris has mentioned this in the past. On the True Blue hoses, as you're tightening them down, sometimes they're a little bit more difficult than regular hoses to tighten. They just are. Sometimes I kind of rock them back and forth. And I notice when they feel snug, the hose will still kind of rock. You know what I mean?
It's just touching it. It's kissing the gasket. So it finger tight's all you need to tighten those down.
So even if it rocks, it's okay.
It's okay. Yeah. It's totally fine. Yep. And those clamps, you just finger tight. You do not crank on those like the hose. You could actually put a system in a vacuum, and you could take that clamp, though, like the aluminum clamp, off, and it would still hold a perfect vacuum. Because if you look at that hose with a gasket goes around on the clamp, there's actually a groove, and there's a piece that pops through there that doesn't allow that clamp to squash that O-ring. You can't crush the O-ring in there. So all it's doing is holding the end on the hose. It's just holding it there so it doesn't fall off. It does not have to be, it will hold itself under a vacuum. And those are KF fittings. Those have been used in the vacuum industry, I don't know, probably since the 30s. I mean, that's an engineered solution for vacuum. That's not something that AccuTools came up with. It's a pretty standard design for a vacuum fitting. But the thing I see most people screw up is they over tighten those clamps. They're like, cranking them on so tight that it's ridiculous. And then the just like you said, just take them up finger tight. You don't want to put a wrench on there or pliers on there and snug them up so they don't move, because the gasket's just got to kiss the end of the end of the flare fitting, and it's sealed. So yeah, you don't need to over tighten them. But anybody that's got bad fittings, if you go to AccuTools website, there's a contact us thing. There's a phone number there. Just call and they'll take care of you. So
very nice.
I don't know. Is there anything else interesting in the chat we missed?
Let's see. We just got a couple of people saying, "Oh, how's your electric bill, Jim?"
I don't know yet.
Yes,
I don't know. I'm interested to see because it's running. So this thing, it uses about anywhere from about 3 amps to about 7 amps. It's a 3-ton unit. So the highest I've seen it run, I have seen it peak out one time at about 11 amps for a short blip. But aside from that, it's running somewhere between 2 and 7 amps of and mostly on the low end, below 5 amps. It runs a little higher in heating than it does in cooling for whatever reason. Probably because on that inverter system, they're running up the they're running up the temperature split, so it's as high as they can get it. So what's really cool with this thing is, like I think the coil runs up to like 380 pounds of pressure. So it'll run up as high as it can, and it's all basic across the. Once it hits that threshold, it just starts backing the inverter down. So the higher your supplier temperature is, the less the delta T is across the coil, because the inverter, will just ramp up as high as it can to get the heat up as hot as it can. And then it just backs off as the house is warming up. It's just continually backing down. So it's really interesting technology. But I think like when you're running in a heating mode, it's like you're running on a 95-degree day year round, it's because it's always running at maximum head pressure. Where in cooling, it throttles it back even further.
Yeah. Cool. Let me see here if there's any other questions I see here. Do you have any more questions, Adam?
I don't think so.
So somebody's got one on there, the curious HVAC guy. He's very curious. He's got a lot of questions. What is the actual cost of a qubit, and what does it mean? A qubit, think of it like a prepaid gift card, right? You buy $20 a qubits is 5 tests. So it's basically a qubit's equal to $1, right? It's $5 per system per year. And you put qubit. The reason we did qubits, everybody goes, well, why the heck did you do that? Why can't I just buy them? Well, there's two reasons. The primary reason is so we could have the ability to share credits amongst a company, so that you can have one owner load an account, then everybody that's associated with that account can use those qubits. So you don't have to have individual qubits for each account that you have, right? And the other reason that we did qubits was so that we didn't have to charge more, because you have to go like on our website and load qubits up. If we did it through like the App Store or Google Play, you'd have to tack 30% on, because everybody wants a piece of your business, right? So it was also a way of, and it's also a way of keeping the cost down, so to, try and keep things affordable. So, and the other thing is not to have a subscription. So you can get it started with MeasureQuick for like $20, right? And if you're that hard up, we'll put $20 a qubits or free bits on your account, so you can test drive it. I mean, it's not a big deal. If you want to test drive MeasureQuick, just call or shoot us an email and ask, and we'll take care of you. And but that's all they are. It's just think of it like a prepaid gift card.
There you go. Someone's asked me to look at his question. I have no idea where it is. Can't find it. Told him to post it again.
So going to add field. Are you going to add field piece meters to the list? Yeah, you didn't.
They'll be on by the end of the month. Yeah.
Oh,
we're wrapping that up right now. So
that's awesome.
Yeah. The only thing that's a good meter, but it's not near as two things. It beacons the signal. So at first I thought the redfish meter was like, I didn't like the idea that it connected. I really like the idea that, like the field piece probes all beacon their signal, but a direct connection reads a lot faster. So it reads like 4 times a second when it's direct connected. Think about like earpods and stuff. They're like direct Bluetooth connection. The throughput's really high. So the redfish meter, it reads on the app really, really fast, where you only get like 1 reading a second off the field piece. The other thing is with the redfish is it measures power. It measures power, volts, and amps all on the same screen. So 1 reading, you get all 4 measurements. You get volts, amps, power, power factor. With the field piece, you got I think it starts volts and amps. And you got to go all the way around the meter to get the power. And because it's an individual measurement. And if you go past off, then the Bluetooth disconnects. So you got to go around the dial, because if you go past off, it's going to shut the meter off. The Bluetooth disconnects, and then you got to turn it back to power and then turn the Bluetooth back on. So it's a little bit clunky. I mean, it works, it'll pull in all the readings in the MeasureQuick and that kind of stuff, but it is a little bit clunky user experience compared to the Redfish. So, but I know a lot of people are field piece fanboys, and that's good. It's a good meter. It's just, this is why like we're really telling manufacturers, you got to work with us a little bit more closely, because we want to help you make better tools for MeasureQuick, because we understand the use case a little bit better than they do, and how we want to use the product to get an end result, right? You just can't throw a radio in something and say it's a great tool. I mean, look at what early testo probes, right? As soon as they made radio probes, what do people want? More distance, right? It's like this, and the guys in Germany are like, but it's wireless, and they're literally looking at one hand and the other and going, there's no cord, right? I'm not kidding you. They really, that's what they were thinking wireless was, and they didn't realize people wanted to go 150, 200 feet. They're like, well, why would you want to be over here when the measurement's over here? But they didn't understand the use case, right? And then you get other companies that see where those companies have sort of been challenged. They go, oh, we'll fix that. We'll put in a radio that'll do 300, 400 feet, right? And so this is the kind of stuff we see in the industry all the time. And we really, with some of the manufacturers, reach out and say, hey, we want to make this new tool. How would you like to use it MeasureQuick? So we can like help them say, okay, well, first of all, here, you need to do this, this, and this. We need to make this measurement, and you got to make sure these are close together so it's easy to do. Just stuff like that. Just think through it a little bit before it's designed, because after the fact, it makes their product look bad, and it makes our product, not saying look bad, but it does. It's just not as elegant as we'd like to see the final solution, right?
He posted his question again. Maybe one of you guys could. I'm just having a hard time understanding it.
Who is it?
See chat. Go ahead. You could make it.
I'm trying to see the chat. I don't know.
Who is it?
Boardington. Bob Reddington.
Boardington.
Sorry, man.
This freaking guy.
Sorry, Bob.
How do the field piece JL3 KM2 manometers appear on MeasureQuick? As just a number or a virtual gauge?
Right now there's actually both. So it does have a virtual gauge where it does total external static pressure. But right now it's in the toolbox, you get the number, and then we're showing total external static pressure on one of the gauges. And then it also, if you go into the indoor measurements, you can see the return air static and the supply air static individually, as well as the total external static.
Oh, it's a double port manometer.
Those are single port.
Yeah, two singles. They come in a pack.
Yeah.
Gotcha. Yeah. These numbers.
That was one thing that I got a little confused on, like in the beginning, because I'm like, all right, I got all these. I actually think I messaged you because I was watching one of your videos, and you're like, yeah, I got 17 manometers connected right now. I'm like, whoa, you have a lot of manometers. I only have 2. And you're like, yeah, I use them all the time. So, well, I'm going to order some more manometers. Let's do it. So I connect everything. I get everything ready. And I'm like, what the hell are all these things? I'm looking in the toolbox, and I realize it's easier to kind of go one by one as you're placing the tools when you're.
Well, the other thing I do is I take a fine point Sharpie marker, and I write like LLT, SLT, DLT, manifold pressure, MAN, induced draft, whatever. I mark every tool. So when I pull it out, I look at it, I see right what it is, because it's already mapped in MeasureQuick. MeasureQuick will remember all the mappings, but just like for deploying the probes, I don't want to have to look and see what number is this one and what's it mapped to. I just want to grab it and plug it in wherever it goes.
Makes sense.
So I'll become pretty dedicated, to what they're doing.
Average added product to be supported. Measure also curious napkin, ion gauge.
You got to read it out loud, Joe, if you're going to read it.
That's a long question.
What is the level of effort and end-to-end time on average to add a new product that is supported in MeasureQuick?
It depends. It really depends. So some of the manufacturers, they give us zero support. They're like, if you can figure it out, you can use it, right? Because sometimes I think some of the manufacturers, some of them probably order stuff from China, and they don't know how it works, honestly. So some of that stuff never even sees MeasureQuick, because we just don't want a bunch of crap in MeasureQuick, because a lot of times garbage in, garbage out, right? So we get calls, people ask us to incorporate tools in, and we look at the tools and we're like, no. It doesn't have good measurement, or there's no support with it, but we have to reverse engineer, like a lot of the stuff we do. We have to reverse engineer it to figure out how it works, and parse the Bluetooth signal coming out of it, because the manufacturer doesn't provide us support. So some of them take us a day, and some of them, like the combustion analyzer, the Blue Flame, took us probably 3 or 4 weeks, because that one, not only does the app get the readings off of, but you can also start and stop it. You can change the modes. So you got to look at like a Blue Flame has, CO, it has O2, it has the stack temperature, it has the manometer, it has the two differential temperatures. So you got like seven probes on it. And then they all do all these calculations, all this stuff. So that's like a really complex instrument. We might never do another like full-blown combustion analyzer again, as hard as that was, without having like some support documentation behind it. And other products, we literally can turn them on, see what they do, and hook them up, get them running in short order. The thing is that we don't ever hook a product up without permission from the manufacturer. So, because we don't. It's sort of the Wild West out there right now. We don't know. I don't think anybody definitively knows what the law is with that. So we just, to avoid getting into an argument with somebody, we just, if they don't want us to incorporate it, we don't incorporate it. If they do, we do. But documentation is a huge thing, and so it's all over the place when you ask how long it takes to put something in. And some products too, like we look at them and they're like, we're trying to figure out how we can make it more user friendly for MeasureQuick, because the last thing we want to do is have people go out and buy something and they're not happy with it because it doesn't work well with MeasureQuick. So we're like, sometimes just trying to figure out a schema that we can make it all work takes time too. So.
Very good.
Yeah. I think we answered everybody's question.
All right. Well, I finished that little glass of bourbon up, so we probably had to call it quits for the night, I guess.
Yeah. You didn't want to talk about it, Adam?
What's that?
Or the little gift.
Oh, no. That's all right.
Okay. Cool.
Hey, it was a nice gift. I will never not accept bourbon. So
good to know.
Yeah.
Well, we appreciate you spending your Friday night at your lounge office, and awesome. Thank you very much.
Yeah, it was good, guys. Appreciate the time.
I'd like to at some point too, when you do figure it out, let me know. I'd like to come over by your MeasureQuick headquarters and do a little bit of training. I think that would be awesome.
Yeah. I'm trying to get some of that scheduled. I had a bunch of service managers that I've been training over the last couple of weeks, and I'm trying to get everybody through and done. So I've been swamped between that and some programming we've been doing, testing. So, but yeah, we'll get you, we'll get something up on the board pretty soon.
Sounds good. All right. Well,
sorry, one more second. Appian, Al Anonymous, he's talking about Appian support. What do you mean Appian support?
Oh, maybe he's asking, are we ever going to include the Appian gauges and
the gauges? Okay.
And the stuff. And we've reached out to them, I don't know, 2 or 3 times, and no interest. So,
Jim's trying, guys. But hey, what are you going to do?
Yeah, that's like Fluke's another one that does the same thing. They're like, they're on their own world. They're like, we don't need you. We can do this all on our own. It's like, okay, well, whatever. Yeah. So,
all right.
We're cool. Good. Well, have a good one. Bill, do you want to say any final words?
Hey, always a pleasure, Jim.
All right, guys.
See you next time.
Yep.